Hi everyone, welcome to the channel. Today we are going to study Laurent series, a part of complex analysis. Here is a statement where a function f of z is analytic in the region, that is in a ring shaped region R bounded by two concentric circles. So let us try understand this by drawing the pictures. So we have two circles, okay. Exterior circle will denote as C and interior circle denoted as C1 with the radius. So let this be the center of the circle. So one radius and the extension will be the another radius. And it's clearly given the radius of R. The radius of R should be greater than radius of R1 with center at A, right? Then for all z, so it's clearly given f of z is analytic in the ring shaped region. So this is the annular region. This is the annular region of z. So this is the region which you have to find whose function is analytic by using Laurent series. Then the function f of z will be a0 plus a1 z minus a plus a2 z minus a the whole square. Similarly, you have positive expansion. Along with that, you have negative expansion. Laurent series contains both positive series and the negative series. So the negative series is a minus 1 z minus a whole power minus 1 plus a minus 2 z minus a whole power minus 2. So this expansion has been summarized for summation of positive terms and summation of negative terms. Here, positive term if you get as a solution, then this Laurent series is also called in that case as Taylor series. If you get a combination of both positive terms and negative term, then this is an expansion of Laurent series. And an is defined as 1 by 2 pi I closed contour f of t divided by t minus a whole to the power n plus 1 into dt. So one important point when it comes to solving problem is mod z value will be less than 1. This is a condition where this entire series has to converge. So this is very important when we are solving problems. Let's start with the first question. Expand f of z is equal to 1 by z minus 1 into z minus 2, and they have given the region where this function needs to be analytic and what type of series you get. If you get the positive terms, then this function goes to Taylor series. If you get this expansion to having a combination of both positive and negative functions, then this expansion goes to a Laurent series based on the given range or region. So first question is mod z less than 1. Write the given function and always make sure the denominator has to be independent of product of terms. So we can apply partial fraction technique which separates these two functions as two different terms. So here after applying partial fraction we have z minus 2 minus 1 by z minus 1. Next step, after you separate it as two terms, see the region. The first region is given as mod z less than 1. So mandatory condition when you're solving a problem for the series to converge, the mod z value should be less than 1, right? So it's already less than 1, so we don't have to do much manipulation here. So you need to remember one more expansion, the binomial expansion of 1 minus x whole power minus 1, because all our terms will have denominator z minus 2 or z minus 1, which we will take it to the numerator, where this formula will help us to proceed for the simplification. But this formula should have 1 minus the function, so that we need to be very clear. 1 minus the function. So the given function f of z can be written as 1 by z minus 2 minus 1 by z minus 1 has 1 by, I need z minus 1 form. So 2 has to be taken out. So when I take 2 common out, this will be divided by the first term minus 1. Here it is already in the form z minus 1, so I can retain it as z minus 1. As our formula says, it is 1 minus variable. So I have taken minus sign in both common and have raised it to the numerator. So by raising you will get minus 1 power. I have just taken minus n because I had variable minus 1, but we need the formula 1 minus the variable. So start simplifying. This minus n we have taken out, minus 1 by 2. 1 minus x expansion we have applied it here. Similarly, minus of minus plus 1 minus z power minus 1. Instead of x we have z. So it's 1 plus z square plus z cube and so on. So now you can start adding the like terms. So the like terms, either you multiply this minus 1 inside, minus 1 by 2 inside, and start with all the terms. So I have multiplied minus 1 by 2 inside. I'm going to start adding each terms. So first term is minus 1 by 2 plus 1. The next term is z can be taken common. So it is minus 1 by 4 plus 1. Again plus z square can be taken common out. So it's minus 1 by 8 plus 1. And again z cube can be taken out and so on. The term keeps on existing, right? So start adding the terms. On simplification, we have got 1 by 2 plus 3 by 4z plus 7 by 8z square and so on. You can see this function for mod z less than 1 gives all positive values, right? So all the values are positive terms, and powers of z is also positive. So this series can be told as Taylor series as well. So now let's come to the second region. So the region is for 1 less than mod z less than 2. After partial fraction, we have got 1 by z minus 2 minus 1 by z minus 1. This is for the same problem which we are doing, but the region is different. Okay. So the first question, when you have separated the function, keep the eye on the region. So what is the region given here? 1 less than mod z less than 2. Remember, mod z should always be less than 1. So we can divide this region into 2. So one is 1 less than mod z and the other one is mod z less than 2. So you need to rewrite such a way that mod z is less than 1. This is a condition where the series converges. So I can rewrite this as 1 by z is less than 1. That means this is a function of z whose value is less than 1. I have taken the z to the denominator. And here to make the RHS 1, so I can take 2 to the denominator. So these are the two conditions which you have to maintain when you are solving problems. Always make sure the RHS has to be 1. To do that, either you shift the constant to denominator or you shift z to the denominator. So as per the data what we have, we need to convert this into series. So what I have to do here, the series exists for 1 minus x to the power minus 1. So I need 1 here. So z minus 2. So can I take 2 common out? So it is z by 2 minus 1. And here I need to have z minus 1. So in this case, you have to see you have got this term z by 2 on the first expansion. To get 1 by z, what you are supposed to do? You have to take z common here. So what we get? 1 minus 1 by z. So that 1 by z and z by 2 both exist in your f of z, which helps you to use and convert the series to converges form. Okay. So 1 by z and z by 2 are the term less than 1 and less than 1 which exist in our f of z as well. Now shift this to the numerator and use the expansion of 1 minus x whole power minus 1. So I have just taken minus sign common because I need 1 minus x form for the first term, and for the second term we have just raised it to the power, that's all. So now we can use this expansion. What is the expansion? 1 minus x power minus 1. So it is 1 plus x square plus x cube and so on. Start using this concept here and you have to just simplify the terms. I have expanded both the terms by using 1 minus x the whole power minus 1. Now you can take the constant terms inside, okay, and proceed for the final simplification. So it's 1 by 2 minus 1 by 2 minus z by 4, actually minus z square by 2 square is 4, 4 into 2 8, and it keeps on going. Similarly, I am multiplying this minus 1 by 2 is minus 1 by z minus 1 by z square minus 1 by z square into z 1 by z cube, and it keeps on going, right? You need to add the terms, okay, but see the terms here, we have z and here we have 1 by z, so we have a combination of both positive power of z and negative power of z. So it is very clearly seen that the series is a combination of positive powers and combination of negative powers. So when you have combination of positive series and negative series, this becomes the Laurent series. If it has only positive power, then it is the Taylor series. If it have a combination of positive and negative, it can be categorized to Laurent series. Coming to the third question for a given function, the region is mod f of z, the region is mod z greater than 2. So you need to take the function, apply partial fraction, that is mandatory since we have already done, and we are doing one problem with different regions. So I am using the same partial fraction. Mandatory condition, mod z has to be less than 1. So how can I convert this region to less than 1? So mod z greater than 2 can be written as z by 2 greater than 1. That is one possibility, but I need in the reverse form. Either you can take reciprocal, when take the reciprocal you will get the inverse function, or you can write 2 is less than z. The same condition I am writing it here. So I can write 2 by z less than 1. So this will be fine. Or you take this reciprocal. So when you take reciprocal, it is 2 by z. Inequality will change, right? So any one you can use it. So you have to make clear the given function should have 2 by z term so that you can use the application here. So for that, it's very clear I need to have 2 by z. So I can write this as 1 by. To apply 1 minus x power minus 1 expansion, I need to have z minus 1 or 1 minus z. This 2 is disturbing me in the first term. So take 2 common out. So what we get? Z by 2, correct? Z by 2 minus 1. But please check what should be your range. The range should be 2 by z. So we cannot use this. So what is another way of finding it? Instead of taking 2 common out, okay, instead of taking 2 common out, I need z in the denominator. So I'll take z common out here. So when I take z common out, I have 1 minus 2 by z. You can clearly see 2 by z, it is there in our function. Minus 1 by z minus 1. Since the range mod z is greater than 1, here also the inequality fails. So can I take z into 1 minus 1 by z? So repeat the same procedure. So 1 by z, I can write it as 1 minus 2 by z to the power minus 1 minus 1 by z into 1 minus 1 by z power minus 1. Apply the expansion of 1 minus x whole power minus 1. So we get 1 by z into 1 plus 2 by z. So 2 square is 4 by z square, 2 cube is 8 by z cube, and so on. Similarly here I have 1 by z into 1 plus 1 by z, 1 by z square, 1 by z cube, and so on. On expansion and simplification, so you have some terms plus 7z power minus 4 plus 3z power minus 3 plus z power minus 2, and so on. So it has only negative term in the series. Coming to fourth term of the region, it is given 0 less than mod z minus 1 less than 1, and f of z is 1 by z minus 2. After applying partial fraction, 1 by z minus 1. So consider the region 0 less than mod z less than 1. This doesn't have any implication on our function. So mod z minus 1 less than 1. So it's very clear our z function is less than 1. So we don't have to simplify anything. Here we don't have to do anything because 0 less than z minus 1. So 0 will be less than the given value 1. Okay. So the given function f of z, you need to try to alter it in this form, z minus 1 form. So I can write z minus 2 has z minus 1 minus 1. Minus 1 by z minus 1. This is the easiest approach to get the solution. And it's very clear z minus 1 is less than 1. So you don't have to take anything common out, right? So you can just directly take minus sign and shift this terms to the numerator term and simply. So I've taken a minus sign common out and shifted denominator terms to numerator with inverse power and start applying the formula. So what we get, minus of 1 plus z minus 1 plus z minus 1 the whole square and so on, plus 1 plus z minus 1. The further simplification is not required because it's very clear it is a combination of positive power of z minus 1 and negative power of z minus 1, which gives the Laurent series. So here in Laurent series you should be very clear about taking mod z less than 1. This is going to decide your functions to be a Laurent series or Taylor series, and this is mandatory condition. Why? Because the series converges at this point. So I hope this concept is clear to you, and these 4 problems are highly used in all the fields of engineering and degree. So thanks for watching. Meet you in the next video.